So after looking at general properties of functions in chapter 1 and 2, we're going to specifically apply it to quadratic functions in chapter 3. We're going to start out by graphing quadratic functions. Now, I went back to look at the exit exam for Algebra 1, which is for most of you, maybe a class you took 2 years ago. But graphing quadratic function was part of the exit exam problem. So most of you should have done something like this in Algebra 1. So hopefully this is a review for all of you. But what we are going to start with is reminding you that in a quadratic function, the graph, just like a linear function, the graph is a line. In quadratic function, the graph is called a parabola. Parabola has special properties that we'll talk about in pre-calculus. But for now, you just need to know that there are a quadratic function is a polynomial function where the highest degree, the highest power, which is called the highest degree, is a 2. So it's a second degree polynomial. So you have an x squared term, which is a quadratic term. You have a linear term, which is a first degree term. And then you have a constant term. Okay? And when you write it as a f of x equal to ax squared plus bx plus c, when you write it in this form, it's called written in the standard form. So to begin with, you need to, they want you to start out by just graphing using plugging in points. You just simply choose, without knowing the line of symmetry, you would just have to blindly plugging in 0, 1, 2, 3, 4, and hopefully you get a point that happened to be the vertex. Now these questions will kind of happen to work nicely, but this is not a very smart way of graphing these problems, so I'm not even going to have you do the guided practice. Instead, we're going to jump into something you should have seen before, using a line as the axis of symmetry. Because quadratic function parabolas has a line of symmetry, a vertical line of symmetry. So if we can find that line first, then it makes more sense to plug in points around that line in order to get the shape of the parabola. The point, the lowest point or the highest point of a parabola is called the vertex. In this example, the vertex is the point 3, -3. So here is the general property of a quadratic function that we would be able to find in every quadratic function graph. One, you have the line of symmetry, which is -b over 2a. Then every point on the right will have a vertical line of symmetry, so there will be a twin brother, if you will, on the other side of the line of axis of symmetry. And then your vertex will be at the on top. It will sit on the line of symmetry, and it will be either the lowest point if it's a right side up parabola, or if you have an upside down one because you do a vertical shift, vertical flip over the x-axis, then that point will be your local maximum. Actually, it will be your global maximum because that will be your biggest value in the whole function. So to graph, instead of plugging points blindly, you would use x equal to -b over 2a, which is the line of symmetry. In this case, -b is -6 over 2a. A is a leading coefficient, which is 1 in this case. -6 over 2 times 1 will get you a -3. So you go to -3, draw your line of symmetry, and then you plug in that 3 into your original function, which give you the number -11. And then you just plug in any point to the left or right of the line of symmetry. 0 is usually a good one to plug in because it's easy to plug in 0, which give you -2, which means the other side in the same distance away from the line of symmetry, axis of symmetry, will be also -2. And then you just have to connect those dots into a shape of a parabola. So here is another example of a quadratic formula written in standard form. Make sure you write it into ax squared, which means the coefficient of the highest degree term has to be your a, and then the linear term, and then constant term. Make sure you write it in that order before you plug it into negative b over 2a. Once you figure out that it's negative 2, you plug it into the function to get negative 7, which is your vertex. And then you would go to the left and right of that input in order to get the shape of the function. So let's go ahead and have you try this one. Go ahead and pause the video, try this problem, and when you have after you have done it, you can press play to see my answer to compare it with yours. Okay, so number 2, it says, consider f of x equal to negative 5x squared minus 10x plus 6. So the first thing we're going to do is find the y-intercept. That's easy. Just have to plug in 0. The y-intercept is equal to 6. It's always going to be the constant term, so that's the easy one to do. And then equation for the axis of symmetry will always be x equals. Okay, so it's a vertical line, so it's x equals negative b over 2a. This is already written in the standard form from the highest degree to the lowest. So negative b, so that's negative 10 over 2 times a, which is negative 5. These two cancel out. You still have one more negative. 2 times 5 is negative 10. 10 over negative 10 is equal to negative 1. So my line of symmetry, axis of symmetry is x equal to negative 1, which also means the x-coordinate of my vertex is negative 1. Vertex. Now, to find the value that include the vertex, I will do a t-table, t-chart. So I want my vertex to be in the middle. I will go up maybe 2 units. I will also go the other direction 2 units. So first, let's plug in negative 1 into the original function. That is negative 5, negative 1 squared, minus 10 times negative 1, plus 6. 1 squared becomes just 1, so negative 5 plus 10 plus 6 is equal to 11. So that is going to be my vertex. We already plug in 0. We know 0 is 6, which means the same direction over on the other side will also be 6. You can always plug it in just to double check, but it should be 6. And then let's plug in 1. That's negative 5, 1 squared, minus 10 times 1, plus 6. That's negative 5 minus 10 plus 6, which is negative 15 plus 6, which is negative 9, which means the same direction away will also be negative 9. So now we can use this information to graph the function. I go to negative 1 and positive 11, 5, 6, 7, 8, 9, 10, 11. I go to 0 and 6, which is right here, which means negative 2, also 6. Let me go ahead and draw the line axis of symmetry, which is x equal to negative 1. And let's go ahead and plug in 1, which is negative 9, which is right here, which means negative 3 is also negative 9, and I end up with a upside down parabola. So again, first figure out where the x value of the vertex is by using the axis of symmetry, and then plug in number that is close to the axis of symmetry in order to graph your function. So it should be intuitive or common sense that since it's symmetrical, the vertex will have to be either the minimum point or the maximum point of the curve. And we've been looking at this in chapter 1 and 2 anyway. So make sure when it asks for the minimum value or the maximum value, you only give the output, just the y. And if it asks you for where the minimum maximum value is, then you give the x as an additional info. Like it says here, the y coordinate is the maximum value or the minimum value, not the x. So here's an example. You're given a negative 4x squared plus 12x plus 18. Because the leading coefficient is negative 4, you know that it's going to be a vertical flip of the original parent function, which means it's going to be a upside down graph. So we know that this graph will have a maximum value. Now, to find the maximum value, we know that value is going to be at x, where x is equal to the axis of symmetry. So we do negative b over 2a, which is 1.5. When we plug in 1.5 into the function, we get a 27. So we know that the maximum value is going to be 27. Stated domain and range of the function. We know that for quadratic function, there's domain is all real numbers. And the range, because 27 is the maximum value, the range has to be less than or equal to 27. Go ahead and give this problem a try. When you're ready, you can press play again to compare your answer with mine. Okay, number 3. Determine whether or not the function has a maximum or minimum value. The leading coefficient is a positive 4, which means we have a right side up, not an upside down graph, which means the vertex is going to be a minimum value. The minimum value again will be at the line axis of symmetry. So I use x equal to negative b over 2a. Negative and negative cancel out. This is equal to 24 over 8, which is equal to 3. So when I plug in 3 to the function, f of 3 is equal to 4 times 3 squared minus 24 times 3 plus 11. This is 36 minus 72 plus 11. Negative 36 plus 11 equal to negative 25. So negative 25 is my minimum value. Therefore, my domain is going to be all real number, because quadratic function always have domain as all real numbers. But my range is the output where all the output is minimum value, so it has to be greater than or equal to negative 25. Okay, or you can just write y is greater than negative 25. So the standard does require you to apply quadratic function into real world application. When we, I think, did this in Algebra 1, this is one of the more challenging word problems, so make sure you look over this example so that you can handle a question just like this one. In the example they give you in the book, Eddie is organizing a tournament. He charged $20 for the 80 players, and then every time he raised it by $5, five people would leave the tournament. So he used this information to figure out how much he should charge in order to maximize his revenue. So what we need to do is we need to write out the problem, and we're going to use x as a number of times the price increase. So every time x increased by 1, the price increased by $5. And every time you increase the price, there are five people that left the tournament. So the pool, the money that he collects, is going to be 20 plus multiple of 5s times the number of people minus 80 people minus multiple of 5, because every time he increase, he get $5 more, loses 5 people. Okay, so when you multiply this out using FOIL, you're going to end up with a quadratic function. These kind of questions will always have a leading coefficient that is negative because you're looking for a maximum value. You're going to use the negative b over 2a to find out where the maximum value is. You plug it back into the function to get $50. And therefore, when you plug in that information into the original question, you end up with the value that they're looking for. So let's go ahead and try guided practice. This time he's organizing a tournament with originally 120 players and $40. This time he's going to raise every $5 he raises, he loses 10 people. So set up this equation, try to see if you can get the answer that's same as mine. When you're ready, you can press play to see my solution. So guided practice number 4. So the money pool is equal to, originally is 120 people times $40. But every time he increased by $5, so X is the number of times he doesn't increase, he would lose 10 people. Now we're going to multiply these two binomials using FOIL. So first term is for a 4800. Outside term, that's plus 600x. Inside term, that's minus 400x. And then last term is minus 50x squared. I'm going to write it into standard form, put the negative 50x squared in the front, and combine that and do plus 200x and plus 4a00. That's my final value. So to figure out how to maximize my value of the pool, so first of all, I notice that the leading coefficient negative, that means I have a maximum value, so that checks out. I'm going to find the axis of symmetry by using negative b over 2a. Negative and negative cancels out. This is equal to 200 over 100, which is equal to 2. That means he should increase the fee twice. So it actually doesn't ask for the actual value of the pool. It just asks you for what should be the entry fee. So the entry fee should be $40 plus increasing $5 twice, which it means is the entry fee should be $50. Okay, that also means that he's going to lose 10 players twice, so you can end up with exactly 100 players for his tournament. Here is the homework that is due on Monday. Let me know if you have any questions. You can email me. I will try to answer it over the email, or we can just wait till check the answer of the homework, and I can answer your question in class on Monday as well. Thank you for watching. Have a good weekend. See you on Monday.